Good morning, America. Imagine looking up and seeing a new star, not in the sky, but right here on Earth. That's the feeling that swept the globe when China powered up its artificial sun for a record-breaking run. This wasn't just a science experiment, it was a bold statement. It signaled that a new era of energy might be dawning. More than advanced technology, this achievement represents hope, a future with clean, limitless energy. For decades, scientists have dreamed of harnessing the power of the sun. China just took a giant leap toward making that dream real. The project, called the Experimental Advanced Superconducting Tokamak, or EAST, is a marvel of engineering. It's designed to replicate the very process that powers our sun. The successful tests are a testament to years of dedication and brilliant minds working together. Why is this such a big deal? Our world is hungry for energy, but our current sources pollute and contribute to climate change. The artificial sun offers a different path, a future where energy doesn't harm our environment. This is the kind of innovation that can redefine our world. It's not just one country's success, it's a milestone for all humanity. The journey to create a working artificial sun is long and difficult, but every step forward brings us closer to a revolutionary future. It inspires scientists everywhere to keep pushing boundaries. The dream of clean, safe, and abundant energy is no longer science fiction. It's a future we're building right now. And that is truly something to be excited about. So what is this artificial sun? Let's break it down. It's not a literal star, but a machine called a tokamak, a powerful magnetic bottle. Its job hold and control superheated plasma, mimicking the sun's core. The sun generates energy through nuclear fusion. China's device does the same, but on Earth. The tokamak is a massive donut-shaped chamber surrounded by powerful magnets. These magnets create a field that contains plasma hotter than the sun's core, over 100 million degrees Celsius. No material could withstand that heat, so the magnetic field keeps the plasma suspended, allowing fusion to happen safely. The nickname artificial sun fits because the goal is to mimic the sun's natural power source. Our sun fuses hydrogen atoms into helium, releasing immense energy. The tokamak uses deuterium and tritium, types of hydrogen that are easier to fuse in a machine. In simple terms, China's artificial sun is a sophisticated reactor built to master nuclear fusion. By creating and controlling a miniature sun, scientists hope to unlock a clean, sustainable energy source. It's a complex project, but the idea is simple. Learn from the universe's own power plant to solve humanity's energy challenge. We're looking to nature for inspiration. The artificial sun is a bold attempt to bring the power of a star down to Earth, and it's a powerful example of science in action. Let's talk about the science, nuclear fusion. Fusion joins two light atomic nuclei to form a heavier one, releasing huge energy. Unlike nuclear fission, which splits atoms and creates radioactive waste, fusion is cleaner and safer. The fuel, deuterium and tritium, comes from seawater and lithium, both abundant. This means the fuel for an artificial sun is practically limitless. Fusion's safety profile is inspiring. It's hard to start and sustain, and if anything goes wrong, the reaction simply stops. There's no risk of meltdown or runaway chain reaction. The main byproduct is helium, a harmless, inert gas. No greenhouse gases, no long-lived radioactive waste. Fusion offers the promise of clean, safe, inexhaustible energy. Imagine a world powered by miniature suns with cheap, plentiful electricity. No more air pollution or climate change worries. This is the future scientists in China and worldwide are working to achieve. Fusion could change everything for the better. It's a sustainable foundation for generations to come. Building China's artificial sun took decades of research, investment, and commitment. The EAST project at the Hefei Institutes of Physical Science began in the late 1990s, but builds on earlier fusion experiments. This was a national priority. Mastering fusion would be a monumental achievement for science and China's global standing. Thousands of scientists and engineers developed components never made before, including massive superconducting magnets cooled to near absolute zero. The device is a symphony of complex systems, showcasing China's growing technological capabilities. International collaboration was key. EAST incorporates lessons from fusion experiments worldwide. China is a member of the global ITER project in France, sharing knowledge and experience. The road was filled with challenges, from plasma physics to materials science. Each step forward was a hard-won victory. The dedication of the team in Hefei has been remarkable. The story of EAST is about people and their dream of a better future. It's a story of perseverance and innovation, and it's a bold pursuit of a grand vision. The EAST project has achieved milestones that captured the world's attention. One breakthrough sustaining plasma at 120 million degrees Celsius for 101 seconds, 8 times hotter than the sun's core. They pushed even higher, reaching 160 million degrees for 20 seconds. These records prove the machine's heating and control systems are working. Another achievement: long pulse operation. In 2021, EAST sustained high-temperature plasma for over 17 minutes, a world record. This shows the reactor's stability and reliability, moving us closer to continuous fusion power. These successes are critical steps toward generating net energy from fusion. While EAST is experimental, its achievements pave the way for future reactors. Each milestone builds confidence in the technology. The promise of fusion energy is getting closer to reality. It's like learning to tame a star. China's artificial sun is part of a global quest to unlock fusion power. The biggest collaboration is ITER in France, involving 35 countries, including the US, EU, Russia, Japan, South Korea, India, and China. ITER aims to produce 500 megawatts of fusion power from 50 megawatts input, proving net energy on a large scale. The US, too, has a long history of fusion research, with recent breakthroughs at the National Ignition Facility. What makes China's EAST special? Its focus on long-pulse, steady-state operation, testing tech needed for continuous fusion power. EAST's record-breaking plasma duration is a direct result of this focus. Globally, there's a mix of collaboration and friendly competition. Projects like EAST, K-Star in South Korea, and others push boundaries in different ways. This competition drives innovation faster. China's rapid progress has spurred other nations to invest more in fusion. In the end, this is a race where everyone wins. The finish line: clean, sustainable energy for the planet. Artificial sun technology could change our world for the better. The biggest benefit: a solution to climate change. Fusion power plants generate electricity without greenhouse gases, letting us phase out fossil fuels. Clean air, a stable climate. This is the promise of fusion. Fusion offers energy independence. Its fuel is abundant and widely available. No more reliance on a few countries for energy, and fewer conflicts over resources. Economically, fusion provides reliable 24/7 spaceload power, unlike solar or wind. Cheap, plentiful energy would fuel growth, power new industries, and improve lives. It could even provide fresh water and clean hydrogen for transportation. Ultimately, fusion is about a sustainable future for humanity. It's one of the most important scientific quests of our time. The work on artificial suns is about building a brighter, cleaner, more hopeful future. And that future is within reach. China's artificial sun signals its ambition to lead in science and technology. This is part of a broader strategy to become a global innovator. By investing in fusion, China is positioning itself at the forefront of the next tech revolution. The success of EAST gives China a powerful voice in the future of global energy. As the world moves away from fossil fuels, those who master clean energy will lead. China is already planning its next-generation reactor, CF-ITER, aiming to produce net energy. Leadership brings responsibility. China can guide international collaboration and accelerate fusion's development. Sharing data and expertise will help the world move closer to clean, limitless energy. The spirit of cooperation, seen in projects like ITER, will be crucial. China's artificial sun is more than a marvel. It's a beacon of hope. The sun is rising on a new era of energy, and it's a future worth striving for.